Hello Earth Science students. For today's lesson on weather fronts, you'll just need a sheet of notebook paper to take notes on, a pencil, and then yellow, blue, red, and purple colored pencils to draw weather front diagrams. It's important that you have these colors. Okay, so let's begin by defining what a weather front is. Weather fronts are weather systems that occur where air masses meet. So we'll just say occur where air masses meet. And when two air masses meet, the warmer one is always going to be pushed upward by the cooler one because warm air is less dense, and so cold air can kind of shove itself underneath warm air. So let's just put that warmer air always pushed upwards. That's important because we know that air lifting processes are kind of what can create clouds and precipitation and stuff like that. So it's important to know that it's always going to be the warmer air mass that gets pushed upward by colder air at a weather front where air masses are meeting. So there's four main types of weather fronts. So what we're going to do is we're going to divide our paper into quarters by folding again. Fold the paper into quarters so we've got four nice equal sections. We'll begin in this one with the warm front. And that would be a pink term if you're using your highlighters. So a warm front occurs when warmer air replaces cooler air. It's not necessarily that it's hot air and cold air, or like really warm air, really cool air. It's just that some air that is warmer replaces some air that is cooler. The type of weather associated with this is like cloudiness, maybe a little bit of light precipitation. We'll say light to moderate precip. Okay, now beneath this, we're going to draw a diagram showing kind of the air movement with a warm front. So let's draw, I'm going to do three lines tall diagram, make a little rectangle. I'm going to divide it in half diagonally like this. Here is going to be my warm air. It's going to be pushed upwards by cold air. So the front is moving in this general direction. Here's my cold air. Let's color these to show temperature. Warm will be red. Cold air will be blue. And as the warm air moves in this way, it's going to kind of like rise up over the cool air. And so here, as it goes upward, here's our cloud formation, and maybe a little bit of light precipitation will come out of those clouds. Okay, and then beneath that, still in the top section here, like here's the fold right here, still in this top section, we're going to draw what a warm front is depicted by on a weather map, so like what you'd see during the weather section of the news. So warm fronts are shown by a line that has red kind of semicircles coming out of it. Oops, that got a little bit weird. It's okay. You guys will forgive me for my poor artistic abilities. Okay, and the little semicircles are pointing in the direction that the front is moving. So like the front is moving this way. So that's kind of like a north to northwest movement of this weather front, this warm front. The warm air is going that way. All right, next we have cold front. Again, that'd be a pink term if you're using your highlighters. So cold fronts happen when cooler air replaces warmer air. So this is a little bit more turbulent of weather associated with a cold front. You can get downpours like heavy rain, gusty winds, and sometimes you can even get cumulonimbus formation. In the summertime, remember cumulonimbus are the thunderhead clouds. So now let's draw another diagram showing kind of what this looks like. So now this time, let's draw kind of a steeply sloping The front is moving in this direction, so the cold air is moving into the warm air over here. Color our cold air blue. And our warm air red. Okay, and so now as this cold air moves in, we discussed this when we talked about cloud formation. This is that frontal wedging process. So with the warm front, it was this really gentle gradient of air mixing, and then in the cold front, it's much steeper. And so as the cold air moves in, it wedges itself underneath this warm air, and the warm air is rapidly forced upward. And so here's where we get our cumulonimbus. We're going to put a little lightning bolt underneath this. This is what the yellow is for, to show a little lightning bolt here, because you can get some cumulonimbus, some kind of stormy lightning storm type conditions. And then for a cold front on a weather map, it's similar to a warm front with how it's shown, except this time it's blue and it's got triangle, like little teeth poking out of it. They're still pointing in the direction that the front is moving. So like if this was on a weather map, this would be a cold front moving to the south. Okay, next we have what's called a stationary front. And in this case, stationary means not moving. So this is when you have air masses that are of quite similar temperature. One is cooler than the other, but they're still pretty close together. So close that when they meet, so we've got warm and cool air meet, and they just mix together, and the front doesn't move. It's like these air masses are going to meet in the middle and kind of mingle, and then it just hangs out there until it like uses up all of the moisture inside of it. So for weather, maybe a little bit of drizzle, light rain, some light clouds, and just kind of overcast, maybe a little bit drizzly outside. Okay, let's draw our diagram. Here's our warm air and our cool air. So this happens when the air masses are moving in opposite directions towards each other. So warm front's going that way, cold front's going that way. When they meet in the middle, you get a little bit of upwards movement of air. Cloud, maybe a little bit of light rain going on in the middle there. Oh, let's label this as warm. Warm air, cool air. Okay. And then on a weather front, or on a weather map, these fronts are like a combination of these two things. So they'll kind of look like this, with on one side of the line, there will be the red semicircles, and on the other side of the line, there will be the blue triangles, which are showing like that the fronts were moving towards each other from opposite directions, and then they hit each other in the middle, and they just kind of hang out there. So we're not going to draw an arrow showing direction of movement because again, they're stationary fronts, so they're not moving. Okay, last type of front we have is called the occluded. The occluded front. In this case, occluded means like taken over, and you'll see why that is a good term for this in just a second here. So this happens when a cold front is chasing a warm front, meaning that there's like a warm front moving in one direction and then there's a cold front behind it, and the cold front can move faster, so it kind of like the cold air moves in over the warm air and like rolls underneath it, and you get some stormy weather. So the cold front overtakes the warm front and then like really rapidly pushes that warm air upward, and again, very stormy weather. Like really fast winds, big lightning storms, stuff like that. So let's draw our diagram. This is a little bit more complicated. So it's like we're gonna have the cold front, like similar to the cold front over here, but then we're also going to have It's like a combination of the cold front and the warm front diagrams. So here we have cold air moving in this direction. Here we have warm air. And here's more cold air. So here's the cold front moving in on the warm front. And as this happens, you get air that's forced upwards in this direction and air that's forced upwards in this direction. And so this is where we get, we'll put a bunch of lightning bolts coming out of this one because this is like really stormy. Like the worst kind of storms you can imagine. Like general, normal kind of storms that we get here in Helena, Montana. This would be from an occluded front. So let's color these. Because we don't get stuff like hurricanes here in Montana because the air is just not moist enough. We're not close enough to the ocean. So occluded fronts are like gonna cause kind of the worst storms that we get. Like big thunderstorms. Think big thunderstorms that we get in the summertime. Okay, and then this is where you need your purple pencil because an occluded front on a weather map looks like it's drawn in purple and it's like semicircles and teeth pointing in the same direction now because you had the warm front going in one direction and then a cold front came up behind it and overtook it and the air like mixed together and forced each other upward. And so that's why it's purple, because it's a mixture of the red and the blue. And again, they're pointing in the direction that the front is moving. So this particular occluded front is moving toward the west.